So in our morning class, we try to see the text operation or text pre-processing step that can help us to select words used for indexing and for searching. As said, given a free text, we have to apply tokenization for identifying words that exist in the free text document. Then either we can use the words as it is, whatever words that are extracted from the document collection, or else we have to apply pre-processing techniques like stop word detection, normalization, stemming. It depends on the application. Mostly nowadays for audio, video, image, if you are designing a text-based image, video, audio retrieval, you may not need to apply such text operation techniques. But if you go for text-based information retrieval for searching within textual document collection, it's better to apply because if we are looking at a words, there are many characteristics that we can identify from a word which are challenging for the IR system to retrieve relevant document as per the user's query. There are many characteristics of words that are affecting the effectiveness of the IR system. When we are measuring effectiveness, we said we mostly use recall and precision. Recall means out of the total relevant documents available in the corpus, how many relevant documents are retrieved by the system. When you are applying normalization and stemming, you are enhancing recall, but at the same time reducing precision. Why? Because precision means out of the total retrieved document, how many of them are relevant, related to the query given. When you are reducing stop words, you are enhancing precision. As a result, even if precision and the recall are inversely related, when precision is increasing, recall is decreasing. When recall is increasing, precision is decreasing. Because to increase recall, we have to retrieve more documents. As we start retrieving more documents, there are irrelevant documents that are retrieved in one way or another. One of the challenges in our system still needs further investigation is how to control the polysemous, synonymous nature of words. Means what? A given word may have multiple meaning, like apple we said. It's polysemous. And also, there are multiple words with the same meaning, synonymous. Ethiopia, Abyssinia, as we said. How can we control these things? Users may be search using Abyssinia. That doesn't mean they don't want to get documents with Ethiopia. Rather than penalizing them, we have to find a mechanism of including both words as one word to retrieve documents relevant that are describing Abyssinia, Ethiopia, 13 months of sunshine, as per how the document is written. That one we'll see when we are discussing about the query operations, because it needs a little bit semantic meaning understanding. It has to understand the meaning of the word. Then as per the semantic understanding, we have to start relating different words with the same meaning. Then we can make our IR system even intelligent, that can understand not only structure of the word, but also semantic meaning of the word. But for now, we applied the three basic text operation: stop word detection, normalization, and stemming. Stemming is a mechanism of conflating words that are further extended by adding either prefix or suffix, infix, circumfix. That means sometimes we are adding at the beginning of the word some characters, prefix, or we are adding at the end of the word suffix, or we are adding at the middle of the word infix, or we are adding both at the beginning and at the end circumfix. Mostly in English, stemmers are trying to control suffixes because mostly in English writing, suffixes are used for defining plural, time, person, place. In addition, there are also challenges when we are designing a stemmer because rather than using a dictionary, nowadays the trend is towards applying rules. And to identify rules, either we can go for in consultation with language experts, trying to define what are the characteristics of words, word conflations, word derivations, how words are conflated. In what circumstance we are adding ing, in what circumstance we are adding ed or d, s or es. If you understand in the setup of the word and what kind of setup of a word is taking what kind of suffix or prefix, then accordingly we can design a rule in reverse way to apply the stemmer to identify those extra suffixes, prefixes added to the word. Sometimes multiple suffixes are added. If there are multiple suffixes, even we have to know the order of adding those multiple suffixes. Can ing comes first before ses, or ses comes first before ing? So the order of adding suffixes in a word by itself is mattering a lot. For instance, in our grammar, English grammar, es is always added when a given base word is ending with ss. In a given word, if there are ss, it's obvious that es is added to form a plural or to take into account place in person or object in general. So understanding the language is critical for designing the stemmer. Still, we can also go for machine learning. We can use machine learning for designing a stemmer, but we need a good corpus. Even nowadays, we are moving to deep learning, which is applied in many areas. In general, the neural networks are effective mostly, but they need a large corpus. Given a large corpus, we can apply deep learning or neural network in general to identify the suffix and the prefix that are available in a given language. Accordingly, we can use them for stemming words into their base word. When we are looking at one of the well-known Porter stemmer in English, they try to design it in stepwise because there are challenges in stemmer. One, as we said earlier, multiple suffixes may appear. Stammers are designed for suffix removal, not prefix, because in English mostly suffixes are added. It's rarely that we get prefixes. So that's why mostly the stammers designed for English language are suffix removals. Even when we are dealing with suffix, there are many challenges. One, multiple suffixes may appear at the end of the word. So we have to understand the order of appearance of suffixes in English words. That means the order of appearance is one suffix appears before another or not. Which one frequently comes first, followed by which suffix? Like when we are using ing and the s together, always ing comes first, then at the end you will get s. Not s first, at the end ing. Like meetings in the example. In meetings, s is at the end. We can't remove ing before removing s. Because to reach to ing, we have to first remove s. After removing s, we can get ing. Even there is a challenge of sometimes the suffix may be greater than even the base word. If the suffix is greater than the base word, what can we do? Sometimes maybe one character only left. In Porter Stammer, they said we have to check whether the remaining base word is with one character or not. So whenever the remaining characters are greater than one, we can conflate the suffix. Otherwise, leave it as it is. But nowadays, again, if the suffix is greater than the remaining base word, it's better not to remove unless and otherwise the base word has a meaning in our dictionary. Like EMENT is a suffix frequently added. Avoiding EMENT from replacement. Finally, we'll get around 6 characters left. So it's okay. Because we are removing 5 of the characters and the 6 of them are remaining, yes. The cement, again, it is constructed using EMENT next to C. If you remove them, only C is left. So that means one character is left with no meaning, which is mixing with other C's. As a result, it's better to leave EMENT in C because EMENT itself is the content descriptor. So the base word itself is cement, not C. So in such a way, the Porter stammer is trying to control the order of adding prefixes and also whenever before removing any prefix, it is trying to check the base word remaining if we remove the suffix. Then accordingly, rules are constructed. So for Amharic, we can see many challenges are there, in fact, because our language, the 18 languages we have, all of them are morphologically rich. Given a word, we can generate as many words as possible by adding prefix and suffixes. Take a word, we can add many characters, single or multiple, and then we come up with many words by taking into account gender, time, place, plural, singular, continuous tense. even past tense, even to describe positions. So there are many attempts around stemming for Amharic also. Around 5, 6 attempts are there, including PhD. So still it is a research area. Nowadays, we are trying to apply even the deep learning algorithm to see to what extent it can help us to identify suffix and the prefix to come up with the base word. Why stemming is challenging? Because sometimes when you are applying stemming, you may get unusual base words. As you said earlier, unless and otherwise we live within the segment EMENT, you may finally get only C, which has no meaning and which is not a word in English language. Even C, when you UAL is also a suffix. If you remove UAL from factual, it doesn't affect, we'll get fact. But if you remove it from equal, the remainings are two characters. And the Porter stemmer remove UAL and leave EQ. That's why nowadays it should be updated. Rather than just checking whether a given base word is at least with multiple greater than one character, even the base word should be as much as possible greater than the suffix that we are removing. If you do that, from equal we can't remove UAL. Otherwise, if you remove Porter's